This is K8BYP with a video on the purposes and uses for matching devices in amateur radio. My video time on this topic so far has been to explain what they are not for. They are not, in any case, and this was known in the Radio Antenna Handbook in 1936, they are not for going between a transmitter and a transmission line for matching. Never. As two examples of matching devices, here's the venerable old Merch, which is called the Ultimate Transmatch. We do not see the word tuner associated with this. What we see inside is their fancy split input capacitor, a heavy-duty ceramic core roller inductor, and another capacitor in a pi network topology. Over on yonder shelf at the bottom is a Drake MN2000, and it does not say tuner. It's a matching network. And over here are two examples of matching networks in little handy bud boxes. There are not three elements in these. There's only two. Toroid inductor and some capacitors in parallel. And as our authoritative source, not opinion, Radio Engineer's Handbook by Terman, 1948. The original purpose for these three component networks was not antennas. If you look at Radio Antenna Handbook in 1936, you'll see where the mistake was made with these things, where the misunderstanding came from. Back in that day, these three element devices, these networks, were used along with or as an option to link coupled networks, which are transformers. They're both transformers of a sort, but a different construction. This is also a transformer, although it's not obvious. It's not two windings on a core. But the purpose of these was to match the high resistance tube plate output to the low resistance of the antenna system, which might have been several thousand ohms down to a few hundred. If we look at the Radio Antenna Handbook, in the section that describes the end-fed wires, the end-fed is not a cross transmission line. It's connected right to the transmitter. Well, that text describes an end-fed as maybe being 2,700 ohms. That's extremely high resistance. Now, that could be made to match a tube output. A tube output could go that high resistance, but many of them don't. So the purpose of these networks is to match the tube plate resistance, which might be several thousand, down to a lower resistive value. Our expert, Terman, says on page 209 that these networks, matching networks, are only pure resistance. Examination shows that these networks made with reactive elements, and the two capacitors and the inductor are reactive elements, have images at their input and output that are either pure resistive or pure reactance. When the images are resistive, the transfer constant is imaginary. In other words, what's in between. While when the image impedances at the output and input are reactive, as in a mismatched antenna system that appears reactive at the feed point, the image transfer has a real component, and so attenuation is introduced. So, immediately, this is not for an antenna system that is incorrectly built and reactive. That's a non-starter. If we look at the Radio Antenna Handbook, it looks like, and they don't make a clear demarcation, but it looks like, could be construed that this matching network is part of the antenna system when it isn't. In an end-fed wire, there is no antenna system. It's a piece of wire that came in the building to the back of the transmitter. And there's exactly that, the random wire terminal. Random wire means end-fed. So ignore those that are ranting about half-wave long end-feds. End-feds are random length. The concept of this network has gotten twisted into becoming part of the antenna system. And as far as a matching device goes, that's wrong. Firstly, it doesn't have to be. And secondly, there is no need for this big, expensive 3-element network to do antenna system matching. There are 3 characteristics of these 3 terminal or these 3 device networks, like the merch. The first one is matching resistive values. Set the knobs just right, 50 ohm input, 90 ohm output, perfectly matched. Secondly, is to introduce harmonic attenuation, upwards of 5 or 6 dB from one source that I read. And the one that isn't obvious until we carefully read this section in Radio Engineer's Handbook about matching networks is that this 3-element network can do phase shifting from about 10 to 170 degrees. So in the old rigs, like the Drake TR3, which has a pi network, that's a 3-element matching network, which isn't absolutely required to do matching, but it also causes harmonic reduction. That rig goes 32 to 36 dB down, almost good enough for today. But it also does a phase shift, and some of that shifted phase is fed back as part of the neutralizing circuit. So complicated setup. In modern radio transmitters that have to adhere to the 42 dB standard of FCC now for harmonics, and to not have these 2 or 3 knobs, and to be able to make a solid state radio, they use upwards of 8-pole bandpass networks with matching elements on the ends. And those both match the transistor output resistances to the 50 ohm antenna system, but also give a lot of harmonic reduction, upwards of, if they're made right, close to 50 dB. So those can't use pi networks because it's not likely that they'd be able to get enough harmonic rejection with just a 3-element network. So the mistake is made in applying these to antenna systems when either it's improper to do so or it's wasteful and unnecessary. The main purpose for such a thing in an antenna system, which is only a resistive mismatch, and remember they can't be reactive, is a 2-element network called an L network. And that's what these 2 things are. 75 ohm antennas, 75 ohm transmission line, 50 ohm transmitter. So a 2-element L network. And the ARRL handbook has a simple formula for calculating these. A little more difficult to make than to calculate. They work perfectly. They fit in a little 2x3 box. No knobs, no adjustments, no nothing. They work great. They just cause a slight narrowing of bandwidth. But my antennas are upwards of 3 to 4 megahertz wide at 3 to 1 SWR. I don't care about that. So there's no need for this 3-element network for an antenna system for matching. And modern radios already have harmonic suppression built in. There's no need for them for harmonic suppression. There's no need for this for suppression for the Drake TR3 because FCC regulations grandfather it in as is. That 30 dB is acceptable. So there's only one real need or use for these, and it's very not obvious, but it's in the phase shifting capacity. This kind of thing can be used to, for example, set up a multiple vertical array for directionality, for switching directions, vertical beams. That can be done with transmission line, but at HF and lower frequencies, the lines become excessively long because velocity is high. So instead of having a bunch of lossy feed line, put a 3-element network in each of the directors, and they can be phase delayed by any amount desired from about 10 to about 170 degrees. So that is the only purpose, only for these 3-element networks. It has nothing whatsoever to do with trying to match a transmitter to a mismatched transmission line. That will not work. If you don't understand that, see my other videos where I've shown proof of it. This matching concept also came from the 1920s and 30s with a gross mismatch of amplifier and transmitter plate resistances of thousands of ohms. And an era where they experimented with these odd forms of antennas like off-center feds and end feds. And they are difficult to match, strange feed point impedances and all that. And before rushing out and thinking you're going to get a multi-band antenna by building one of these, read the Radio Antenna Handbook, 1936, and very carefully note that they say, along with these odd form antennas that admittedly will work on multiple bands, they're poor performance. And that is why many operators are not on the air today. They only work when conditions are good. And that means when there's sunspot activity. We're in the deepest low in sunspot activity, as far as I know, ever. Conditions are horrible. But I'm on the air every day just shocking people with how good my dipoles work, because they're properly built and properly matched. The reason this myth continues to be propagated about these fake tuners is simply for profit. 1956 or 58 Radio Amateur's Handbook, Johnson ad, antenna tuner. That's a lie. They're tuning nothing. See my other videos where I explain that in detail. These are not tuners, they're for matching, and they're not for matching transmitters to transmission lines, especially where there's a reactive condition. So if the antenna's badly messed up, this will not fix it. Fix the antenna. KBYP did it.